Hello everyone. In this video lecture, we are going to discuss about template functions because in the previous lecture, we have already discussed about uh, what is template, the relevance or importance of this templates in C++ for generic programming. Okay, and then also we have discussed about how to create template class. So now in this lecture, we are going to discuss about template functions, which are also called as generic function. We have also we have already discussed that templates are introduced to support generic programming, okay, or to achieve generic programming. So with the help of template function, we can create generic functions. Generic function is what? The logic is same, but the same function can be used on different data types. Okay, logic or the algorithm remains same. Like we have taken example of bubble sort. So bubble sort, that logic remains same, whereas you can make that same function work on integer data type or float data type as per your requirement. So let us discuss about template functions, how to write a code for how to write your generic function, okay, the syntax and all that. So the syntax goes in this manner. We have already, I've introduced this, how to create a template. So template keyword, then class and whatever template you want to create. So you can name it. Now next is the function. Remaining part is exactly same. I'll bring it to the next line so that you will understand it. Okay, so this is the return type of the function, function name and parameter list. So as it is the way you write a normal function, you can write this generic function. Just add this before that function. Then here type is a placeholder. This type is a placeholder, or it is actually a template. Placeholder name for a data type used by the function. This name can be used within the function definition. So in function definition, wherever you want a flexibility as far as data type is concerned, you can use that type, whatever type you have declared here. A specific function created from function template is called as template function. So this way, whatever function you are creating, it is called as either template function or generic function. Now, this is one example. So, with the help of one example, we'll try to understand this concept. So, here, as I told you, we start the generic function or template function with keyword template, then class. Okay, in Angular bracket, we mention class, and here the actual name that you want to give here to this template. Okay, so we are giving suppose t1. You can give any name. The way you give name to variables, in a similar manner you can give name to the templates. So this is user defined. Okay, whereas these two are the keywords. So t1 is the name given to the template. Now I want a swap function, generic swap function, which can swap to integer values, to float values, or maybe to character type of values. So this swap function should be able to swap any two variables of any data type. Okay. So void swap, because swap doesn't return any value back. So void swap, and the input parameter, as mentioned, input parameter can be of type integer, float, any type. So instead of directly mentioning here integer or float, what I'll do is I'll use this T1 here, the template here, okay, or a placeholder, and this placeholder can be replaced with integer, float as per my requirement. So these are just the placeholder T1. So T1 and here A, the first variable and the second variable that I want to swap. And this already we have discussed that swap this function is modifying two values, and one function cannot return two values. So what we do in such situation, we either use call by address or call by reference. So call by reference I have used here. So that's the reason this ampersand is there. It can be normal variables also, but in this swap function I need to modify all these A and B in the main program also. So that's the reason I'm using call by reference. So now one temporary variable, again for this temporary variable, I'm not sure whether it is integer type, float type, because if input type is integer, then it should be declared as integer. If a and b are float, then temp should also be of float. So that's the reason temp also I'm declaring with t1. Okay. Now this is the logic to swap two values. So temp is equal to A is equal to B, and B is equal to temp. So this will swap A and B, and this will be reflected back. The modification done or the swapped values will be reflected back in main. Okay. So the entire logic is same. We have already discussed this swap function earlier with call by reference concept. So exact logic remains same. Only what modification I have done is I've added this template class T1, and instead of direct data type, I'm using this T1 over here. Okay, so that I can use this swap function with for integer swapping, float swapping, double or character type of swapping, any data type. Okay, so this is how you can create generic or template type of functions. Now, in case if you want to use two different, like say in this example, swapping this A and B will be of same type. But situation may arise wherein this first variable and second variable can be of different data types also. And you are not sure whether it will be a combination of integer float or integer double or float double. So any combination can be there. There will be two variables, but can be of different data types. Okay. So in such situation, you need to create two placeholder because you are not sure about the data type of both of these. Okay. They won't be of same data type. In this case, what has happened? A and B, they are of same type. So you have created only T1. But when in some of the function, it is possible that they can be of different data types, A and B. So in that case, you need to create two template classes, T1 and T2. Okay, so class T1 comma class T2. So this will give you more flexibility. Now display function. Say for example, from main, I'm calling display function. And what is the purpose of display? Is whatever two values I'm giving, the function should display those two values. So in first call to this display function, I'm passing integer and character array. So combination is integer and character. Then after displaying that, next display function is to display float value and float. Combination is float comma float. Next can be float comma integer. So any two data types I can pass as to the input parameter. So if situation is like this, that I'm passing two input parameters, but both of them can be of different data type. So if this type of situation is there, in that case, we are declaring multiple templates here separated by comma. So T1 comma T2. Now, if you need more variables, say here, for example, again, third and fourth variable is also there and they can be of different data type. So maybe you can say comma class T3 and so on. Okay. So it is based on your requirement. You can create multiple placeholders over here. Here I have created two placeholders, T1 and T2. So A will be of type T1 and B will be of type T2. And simply this display function is to display A and B. So C out A, B. So the logic to display A and B remains same. Only what I have done is while declaring these A and B, I'm using T1 and T2. So that same display function will work first time for integer character array. Next time it will work for float comma float. And then maybe for the next time float comma int, like I can go on calling this function for different combination. So this is a generic function I have created with multiple generic types. These are generic types, right? So here multiple generic types I have created. So there is no limit, like you can have T3 also, comma class T3. It is based on the requirement of your application. Now, there are some invalid declaration types while declaring template function, which you should avoid. Now, first one is I've created template class T1, okay, the first line. And while defining that particular function, I'm not using this as argument. I'm using it only for return type, okay. So this is invalid. Just for using it for the return type, I cannot use it. Unless and until there is some input argument, I cannot use it, okay. There should be something here. So this is invalid format. Then next is template argument must be used. Like here, I'm declaring it inside T1I. Okay. But like here for input parameter, I'm not using any template. Okay. So here it is mandatory that you should use something as template argument. So at least one of the arguments should be template argument. You can have a combination like with normal data types and template. You can mix and match. Okay. But at least one template argument should be there. Okay. So this whatever I've written is invalid statement or invalid declaration because I haven't used any template argument. Now, next thing is explicit overloading generic function. Explicit overloading generic function is what? We have already seen that implicit overloading automatically happens. Like in this case, implicit overloading is what? First time it is calling for integer and character array. So first instance of this function is created with integer and character array. Next time I'm calling it with maybe float and float. So next instance of this function is created with this combination float and float. So each time we are creating different instances. Okay, so this is nothing but case of implicitly function overloading is happening here because data type is each time data type is different. So function overloading is implicitly taken place, but whereas there are situations wherein explicit overloading of generic functions are also required. Okay, so in those situations you can explicitly overload those generic functions also. Like here example is given. This is just to give an example. It is not a actual situation wherein it is required, but just to explain you the concept, explicit overloading generic function. So in this situation, say for example, I've created a generic swap function. Just I've explained this function to you. And in the same code, I'm having another swap function, okay, wherein I have explicitly mentioned that input types will be of type integer and here temp also integer. So with that data type explicitly, I have created this swap function. So these two functions, for example, I have written in the same program. Okay, so will your compiler accept it? Yes, your compiler will certainly accept it. It is a valid declaration. But here it will be considered as explicit overloading because already one function is there and you have also written one function with integer data type. So this is the case of explicit overloading generic function. So though already generic function is there, you are trying to overload it again. Okay, for some specific data type. If situation arises, if you want, you can do it. That is possible. Okay. So in this case, what will happen? If specific function is there, then obviously priority is given to that specific function. Okay. So whenever there is a call for swap function with two input integer values, it will call this function and it won't give a call to this function. Whenever integer input parameters are there, obviously it will give priority to this function. Okay, wherein explicitly you have mentioned the data type. And now in the same program, if you try to swap to float number, in that case, it will call this generic function. For double, it will call the generic function. But for integer value swapping, it will give priority to this swap function, wherein explicitly you have mentioned integer data type. Okay, so if these type of specific functions are there, then first the priority is given to them. Okay, if these type of functions are not there, then it will call the template function. Okay. Then another possibility wherein explicit overloading is required is this situation. Like I want to define a display function, okay? But sometimes I want to call display function for single value, whereas sometimes I want to call the display function for two values, three values, okay? If that requirement is getting changed, that each time I may call the display function with different number of parameters, input parameter, different number of input parameter. Okay, here I'm calling display function only for one argument. Here I'm calling it for two arguments. So if this type of situation is there, in that case, you need to overload the function template. So here, how to overload the function template? See, for this particular function, I just need one input argument. So I'll create one generic type T1. I'll declare this A with T1 and I display this value of variable. Okay. Now how to call this display function? This is the way I can call. I'll say display 10. So now this T1 will be replaced with int. If I call this display with A in single quote, so this is what is the data type here? Character. So now this T1 for this function called T1 will be replaced as with char. So this is how I can call this function. Okay, so this one template function I have created. Now this same display function I am overloading here, function overloading or template, this generic function overloading is taking place. In this display function, I am having two input arguments. Okay, A will be of type T1 and B will be of type T2, so that I can use any combination of this T1 and T2 for display. So the code again remains same, cout A, and I'm displaying B also here. Okay. Only point here is that this first display function is for one single argument and this second display function is for two input arguments. So how to call this function display function? Whenever there is a call for a display function with two input arguments, say here I am using combination of integer and char. So T1 is integer now, T2 is char. Second display function call is with character array and float. So T1 is replaced as character array and T2 will be replaced with float. Okay, so it will display this character array, that string on the screen, and B is nothing but float, 10.5 will be displayed. So whenever I am calling display function with two input argument, it will call this template function, and whenever I am calling display function with one single argument, in that case it will call this display function. Okay, so explicitly you can overload these generic functions also, it is possible using standard parameters with template. Now, can you use standard parameters also while passing the input? Yes, possible. You can make combinations also, like this display function. Now, this is, see, these two display function we have seen. Then another, one more overloading we are doing here. Now, again, class T1 and T2. We are using only two generic types. So A is of type T1, B is of type T2, whereas third input parameter will always be of type integer. When I'm sure that always third parameter is going to be of integer, whereas I'm not sure about the data type of the first two parameters. Okay, so in that case, I can say T1, T2, whereas third parameter is always integer. So why to take generic type here? Not required. I'll simply say integer. And then I display all these variables. So this type of combination is possible. So while calling this function, we have to take care that third parameter should always be of type integer. First two parameter can be of any type. So when I'm calling display function, first type is char, second is character array, third one is but integer always. Now again another call for display wherein first is integer, second is integer, or float also you can use, but third type should be of integer only. Okay, so what we have seen here is, or what we have learned here, we can make combinations also, combinations of generic types and your built-in data types. Okay. Now what are the restrictions of generic function? If the algorithm or function body is same, irrespective of data type, when can we use generic function? When your algorithm is same, but data type can be different. Okay, then only generic functions can be used. मतलब उसके अंदर का logic वही रहेगा, only data type is getting changed. So in those situations only you can use generic function. Like example, searching, sorting algorithm, wherein logic remains same, only data type can be different for those variables. Okay. But if function implementation also is different according to data type, मतलब उसके data type change हो जाते हैं तो उसका function implementation, that logic is also getting changed. So in that case, you cannot use generic function. Okay, so in those situations, you can use your normal function overloading. Function overloading में क्या होता है? You can define that function again and again with different logic. Okay, so function overloading you can use in that situation wherein, see, generic function to be used when your logic remains same, only data type is different. Generic function is when logic or algorithm remains same but your data type can be different. लेकिन आपके data type भी different है और उसके अंदर का logic भी अलग होगा, तो then in that case you go for function overloading. Okay, so this is about function, generic function or template function. Okay, and this class template we have already discussed last time. With example we have discussed. Okay, so this is one more example wherein I have used a combination. Like here, this template, this should be small case. Huh? By mistake, it is capital. It should be small. So template I have created class T1, and when I'm sure, like here in this case, I told you about this generic function. First two argument can be of any type, whereas third will be always integer. Okay, so I can use combination. So similarly with template class also, I can use a combination. Like I'm not sure about the data type for one data type, but second type will be always of type integer. Okay, like I'm creating a class. Okay, and I'm not sure about the data type of that class. Okay, data type of the array. I'm creating a class array wherein I'm not sure about the array data type. Sometimes I may create array of type integer, or sometimes maybe a float, but size will always be of type integer. Okay, so that's the reason here I have explicitly mentioned the data type of the size. So it is always of type integer. Now, how to create the object? When this type of situation is there, wherein combination is there, how to create the object? This is the way you can create the object. The name of the class is array. So array, you are creating object one. But in angular bracket, you need to mention first is what? The data type that you want to create for this array. So first I want to create integer type of array. So it is int. Whereas second argument is what? Size of that array. So directly I can pass some integer type of variable or any integer value here. Okay. So second parameter should be always of type integer. Okay. So here the data type I have mentioned. So this T1 will be replaced with int and this size is equal to 5. Similarly for second object, T1 will be replaced with float. Okay, and size is equal to 10, and similarly for the third one. So template class can also be created with some combination. It is possible. Okay, and finally one thing, like in place of somewhere in some program, in some books, or maybe on some sites, instead of class you can see type name also. Okay, so that is optional. Either you can write this first line that we write here, no, like here template class T1 comma class T2. So instead of this class here, you can use type type name also. Okay, so instead of class, this type name. So alternatively, whatever you are comfortable, you can use either class or type name. Or in some books or on some site, you may be wondering why this type name is there. Ma'am ne to class bataya tha. So it is possible instead of class, you can use type name also. Okay, it doesn't change the meaning as such. So this is about type name. And one final thing, like export, if you add export keyword in front of this definition of template class or template function, if export keyword is there, in that case you can use this particular template function or a template class in any other file. Okay, in any other file, as means what? Suppose you are having two source files, two files with cpp extension. Okay, in one file you have created the template class, and in another file you want to use it. Okay, so wherever you have created that template class or a template function, just add this export keyword in front of it, so that this template can be used in any other file. Okay, so this is how you can use this export keyword in front of it, and so that it is accessible to other files also. Okay, so this is about type name and export. So this is all about the template functions. So what we have seen, template functions or template classes are used to write generic programming or are used to achieve generic programming. So either you can write generic functions or generic classes based on your requirement. Okay, and the very purpose of this is